Hello, my dear guys. I am before you to teach you a very frequently asked question in the chapter 3 regarding the Wheatstone's principle, Wheatstone's bridge. Okay, never overdo this topic because some people, okay, gehu patthar setu nahi. No, it is not that. I will make it easy for you. It's another name is null method. First of all, there is a circuit, electrical circuit, which is shown here. It's having a battery, and the source contain the positive charge is traveling from here. The positive from it, the current is starting from the positive terminal. It is going over here, and it is splitting into two parts, I1 and I2. Consider this like a river. This river or a road itself, the road of the electrons. Okay, it will have an obstruction when an electron, like a vehicle, is traveling. It will go through some obstruction which is given a P, which is named the resistance. The obstruction's name going over B, and it will come over to the C part, going over the another obstruction named Q, and coming to the point where it started. Next, through the other mesh, the same vehicle going through the next road, having obstruction R and passing over here to the another obstruction S, which is resistance, going over here and coming to the same point. The nomenclature, when it is done, you must name the top part I1, the bottom part I2, and then the connection from here to here, the connection between these two roads, we will name it a bridge. Okay. Oh, that's why we have been given a name, Wheatstone's bridge. This is some person's name. Oh, this is the bridge. What is that word? A galvanometer bridge. And this current I1 will go over here, and the current IG from here, this I1 is split up into two, I1 minus IG. That means this I1 and IG current is going from B to D, and total current I1 minus what is left from here is named over here. Okay, this is I1. It will get split into IG and I1 minus IG. What is left when the current IG is gone through here? That is I1 minus IG. Likewise, when the I2 current comes over here, now this IG current will join over here with this. So the joining force, I2 plus IG, will pass through here and completes the circuit. So all the nomenclatures are given. You know what are the techniques. First of all, I have earlier shown in you in the PCM Guru Bro classes about the Kirchhoff's second law. No, I will make it easy for you, again revising what we have learned. First of all, consider the loop ABDA. ABDA, this left side triangle loop. So from the positive terminal of the battery, it is given negative sign, minus I1. This current is given minus sign. Okay, minus I1 into P, the resistance. Same direction it is having IG, no? So minus IG into the resistance G. Okay, when it come over here, oh, this is opposing this. I2 current is opposing here. This is coming this way. This is coming this way. So I2 is opposing, so plus I2R. This is complete. Second of all, the loop is BCDB loop. BCDB, right hand side triangle. So what is that? Its starting point from the positive terminal. This okay, BC. I1 minus IG is given minus symbol. Then the same when it is going over here, this is opposing now. Then this will give, when it is given minus sign, then this will be given plus of I2 plus IG. This is given. This same direction is also followed by IG, no? So plus IGG. Look, for making our principle as easy as possible, no, this is the thing. Even if you don't know anything about Wheatstone's principle, null method, anything, just write in an alphabetic manner. P, Q, R, S. Okay, alphabet I know. P by Q is equal to R by S. That is the thing, the basic principle. Just understand in a way that these two resistance are the name PQ. The P and Q are the resistance which are in series. That's the main point which you want to write next. R and S are two resistances which are in series. So until this now we have got, but rearranging in such a way that we should get this now. So the first equation which I have taught you, it's multiplied by minus sign. So all this minus will become plus and plus will become minus. This is the thing. First equation. Second of all, this equation which we got multiplying by minus 1, then minus will become plus, plus will become minus, plus will become minus. Okay, these two equations are ready now. 1 and 2 are ready over here. These two we apply. And there is a term called balancing condition. What is a balancing condition? This is the condition at which the current through the galvanometer, through the galvanometer is 0. Why this current is becoming 0? Because at a certain point the potential difference becomes 0. How this can be attained? Because by adjusting P, Q, R and S resistances, no, we can attain this no potential difference over here, so no current, Ig current is 0. Okay, applying that Ig current is equal to 0 over here, this equation. So Ig 0, no, what will be left? This become 0. I1P minus I2R. This is written over here, naming newly equation number 3. Second of all, Ig current is 0. So I1, this will become 0. I1Q, okay, I1Q. Oh, and minus Ig 0, no? So minus I2 into S. Okay, here Ig also 0. This whole thing disappeared. So what is left? These two equations are left. We can make it this minus and you take the whole thing, put it to the right side of the equal sign. So this will become like this now. When we divide, name it as 3 dash or 4 dash. Anyway, just write it. And dividing this 3 equation by the 4th equation. Okay, so I1 will cancelled, I2 get cancelled. What will be left? V by Q is equal to R by S. Okay, this is the null method. This is the Wheatstone's principle. Oh, no, this is very easy thing. You can score full marks. By now you have known the basic points. A balancing condition is there. Potential difference 0. Current is equal to 0. Achieved by adjusting the resistances PQ series, RS series. So not some points which I have to say. This null method is unaffected by the internal resistance of the source. The source is a battery. This null method is unaffected by the internal resistance of the battery and the resistance of the galvanometer. Okay, write it there, right, like that. Interchanging the positions of the galvanometer and the battery does not affect the balancing conditions. What is that? Interchanging this and this, that means this will have a position over here and that position will come over here. Okay, oh, I want to redraw now. Okay, that's it. Let's redraw that thing. This thing will get disappeared. No? That means these two are connected to a galvanometer earlier. No, that connection I am splitting up. Okay, that galvanometer connection I am splitting up and giving into the battery here. Next, what is that? Water all is in the battery position. No, this is over here. No, battery position. That thing is connected to the galvanometer. So here in this diagram, second diagram, so as to make you understand what I have said, interchanging the positions of the galvanometer and the battery does not affect this balancing condition. Just look at this. Here, the battery is here. This battery is replaced by the galvanometer over here, and the galvanometer is replaced by the battery over here. Okay, clearly understand. Very well, revise it. At the balancing point, the effective resistance of the bridge. What is that effective resistance of the bridge? Simply P, Q are in series. Okay, then the resistances are when it is in series, P plus Q is the total resistance. R and S are in series, R plus S is the total resistance. But these things, P plus Q and R plus S, are in parallel. So the equation we will apply, 1 by R effective is equal to 1 by the whole P plus Q plus 1 by the whole R plus S, which are in parallel. No, when it is parallel, the addition of reciprocals give the effective, the reciprocal of the effective resistance. Okay, we can make this thing in more simplest way. That means denominator is R plus multiplying the whole this thing by R plus S. Here it will become R plus S. Into P plus Q into R plus S plus here P plus Q by P plus Q into R plus S. The same thing as this, making the denominator same over here and writing the whole thing. Just putting this P plus Q will come over here. No, this thing when it is put to the left side, it will look somewhat in an ordered form. No, P plus Q plus R plus S by P plus Q into R plus S. This is the thing which you want to study. If any doubts arises, please call me. I will be very happy to hear from you. I will clear all the doubts. Just please subscribe, view and share my channel. Love you guys. Bye.